So before we get going here, I hope that you watched the previous video about checking your solutions to a differential equation, and that it's very similar to checking your solutions to a basic algebra equation, where you take your solution, plug it back in, and it should satisfy the beginning equation. And that's still going to be true when we are dealing with differential equations. The main difference here is that we got to keep in mind that our solution y and the I don't know, words that we're using, y is a function. So our solution is going to be a function instead of a value, and that's the main difference. Now in that video, I'm pretty sure I called the integration that I was talking about at the time the wrong thing. When we are talking about adding c to the integral, so this picture I got out of the book, and it doesn't really go with this, but I think it'll make sense here. Just kind of ignore these bottom ones, the upside down ones, and just concentrate on the ones that are in the first and second quadrant here. So if we took the integral of this, it would end up being e to the x, and then we'd have to add this c. Okay, and so that is an indefinite integral, and I'm pretty sure I misspoke in the video I did before this, so I'll go back and fix that eventually. But all this is saying is that, we just found a family of functions that could satisfy this beginning part. And so, this c would just move this thing up or down depending on what the value of c was. So again, that's kind of what we're going to start with, because we're going to talk about general solutions, and so then we're going to have this idea here. So I do apologize for that. Okay, and so to piggyback off that idea, while we are finding a solution to a differential equation, the order of the differential equation is going to tell us how many of these c's we would have to add. So for instance, if our beginning function was y primed, its solution after integration would be y plus c. If, however, we started off with a second order differential equation, we would still get to y, because that is our solution. Remember, y is our solution. But then we would have two constants that we would have to add. And I guess really, I should back up here. Really what we would have is this situation, okay, where we would add multiple constants. So that is the relationship between the order of the differential equation and how many of these we'd end up going to. If we can, this would be the general solution to a second order differential equation, and this would be the general solution to a first order differential equation. Okay, so here's an example, and again, we're just finding the general solutions to this differential equation. Remember, what we're really trying to find here is y, and so, all we're doing, and the book refers to it as undoing the derivative here. And what that means to us is that we are going to move up a step. I don't know if that's the right way to say it, but we're going to say this okay, so we have now y to the t over here, and then we're just going to integrate this, and I'll do it in steps, right? So then this is going to be 12 t to the 6 over 6 minus 20 t to the 5th over 5 plus 2t minus 6t to the negative first over negative 1 plus our constant. Okay, and so then to simplify this down, that would be the general solution to this differential equation, and you should definitely pay attention. You should be checking your solutions. Okay, so I mean, this isn't really that tough to check. We can just make sure that if we took the derivative of all this, it gave us this over here. Okay, so but this would be a family of solutions now, and it would depend on what we started with, and we will do some initial value problems with that here in a second. So I did want to do one more of these general solution ones just to illustrate the difference between having a first order differential equation and a second order differential equation, but you just treat it the same way, right? We need to get all the way to y of t. Right now we're at the second derivative of y of t, so we'll have to integrate twice on this problem. So in order to save space, I'm not going to show you the integral sign over here on the left, but we are going to go here, and that means we are integrating this left-hand side, right-hand side. Okay, so then, right, we're going to get 5e to the 3t minus cosine of 4t over 4. And then here comes our constant. But that is just y prime. So we do need to get all the way to y. So then, again, we're going to do another integration step. And that will give us y here. And so then we'd have 5/3 e to the 3t minus sine of 4t over 16. Now we do have to integrate this constant, and now we have a new constant that enters into our picture. And so since we got all the way to y, this is a general solution to the original differential equation. All right, so I'm going to do one initial value problem here. And you treat it the same way at the beginning. We do need to get from y primed here to y, and we're going to do that doing the same method as we just did. So we're going to integrate both sides. And so we're going to get that's going to be our general solution. And we've done this stuff before. If you can compare this to our acceleration, velocity, position problems, I mean, you basically know what you're doing at this point. We're going to say that our beginning condition here, our beginning condition here, we're going to use that to find c. So we're plugging in 0 everywhere, setting that equal to 4, and then solving for c. So now we have 4 equals negative cosine of 0 plus sine of, 2 times 0 is 0 over 2 plus c. right? The cosine of 0 is 1, so then since it's a negative cosine of 0, we have negative 1 there. Plus sine of 0 is 0, plus c, and so then we're saying that c is equal to 5. So then our solution, oh shoot, yeah, right there. Right, so then our solution is going to be that. Okay, and I suggest that you take a look at what the book is saying about these on page 551. There's a little bullet point off to the side that I suggest that you read through and take a look at the picture that they have there, because again, these are very applicable skills that we're working on right now. Also, I think it makes sense for you guys to give number 29 a try at the same time. So, but you do want to look at the example number 5. So look through example number 5, and I'll put the problem numbers on there so that you can see, but I think we should be able to get up to 29 now. Please ask questions if you got them.